Good morning, students. This is Dr. GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I would like to discuss about factor of safety. The factor of safety is a safety factor that generally used in the design of the mission members or mission elements. This is a very important factor while designing any component. So, what is this factor of safety and how to take the factor of safety value and what are the considerations we will take while designing a component? Today in this session we will see. The factor of safety generally used to provide a design margin. So, over the theoretical design capacity. So, for what purpose? To allow for uncertainty in the design process. So, what is this uncertainty? So, uncertainty sometimes may occur in the calculations and the material strengths and this manufacturing process. So, this way, this factor of safety depends upon material selection and type of manufacturing and type of load also. We will discuss in this session. The factor of safety means while designing any machine component, always we should keep the strength less than the maximum strength or ultimate strength. So it means at which the component fails, that stress is called as design stress. Design stress or working stress. So always the designer should keep some reserved amount, the reserved strength in the component in the form of factor. So that is called as a factor of safety. So example here, suppose if a component needs to withstand a load of 100 newtons and a factor of safety is here taken 3 is selected, then it is designed with strength to support 300 newtons. So what is this withstand load of 100 newtons? So this is your actual load. So that is our working load. So that component should withstand this load 100 newtons. So and the maximum capacity the designed with strength to support is 300 newtons. So this is maximum load. Clear? But your working load is 100 newtons. So what is the factor of safety here? So generally the factor of safety we can write like this: maximum load upon the working load. Okay, working load or design load. Clear? So here maximum load is 300 and the design load is 100. So 3. That's why here selected the factor of safety value is 3. Clear? So when a component is subjected to fatigue loading, so the endurance limit is the criterion for failure. So we will discuss in the endurance limit and the fatigue failure topic clearly what is this the endurance limit I will tell. Therefore, the factor of safety should be based on endurance limit in case of fatigue loading. So in the case of fatigue loading, the endurance limit stress is the ultimate stress. Clear? And the designer working stress, your actual stress. So you can write sigma E by sigma D. The sigma E here indicates endurance stress. The factor of safety depends upon the various factors. So while designing any component, we will take some considerations. So that is the type of material. And the second one is what is the manufacturing process, and then what is the cost of the component or cost of the material. Clear? So all these affects the factor of safety. Suppose if your factor of safety value is taken higher value, then the cost also will increase. So why? Because the factor of safety so if you increase the factor of safety, you have to increase the dimensions of the component, the dimensions of the machine element. So ultimately what will happen? The cost will increase. Clear? And So that's why always you have to take the factor of safety value within the limits only. Clear? For ductile materials, what is the factor of safety, and for brittle materials, what is the factor of safety? How to take factor of safety? So here represented in this table. Clear? The factor of safety based on yield strength. The first one is 1.5 to 1.25 to 1.5 range. So for what applications? Material properties known in detail. So suppose if you know the material property, so the property of the material in ductile nature, and the property of material is in brittle material. So like that, if you know the material, then immediately you can take the factor of safety while designing a component. The value is 1.25 to 1.5. The factor of safety value should be within this range only. Clear? And operating conditions known in detail. The operating conditions, the temperature, and what is the atmospheric conditions. If you know, then in that case also you can take 1.25 to 1.5. Load and the resulting stresses and strains. So this is another application. If you know the resulting stresses, strains are known to high degree of accuracy, and low weight is important. Clear? Next one is 2 to 3. So for less tried material or brittle materials under average conditions of environment, load and stress, you can take 2 to 3. For untried materials under average conditions of environment and load and stress, better known materials under uncertain environment or uncertain stresses, in that case 3 to 4 you can take. So totally the factor of safety value depends upon material and manufacturing process, and the application also. So while the selecting factor of safety for ductile material, it is the factor of safety depends upon yield strength. Suppose for we were selecting for brittle materials, the factor of safety depends upon ultimate strength only, the maximum ultimate strength. Clear? These are the references we have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.